Now that we've got the basics set up, movement and animations, let's connect everything using Unity's Animator controller. Head to the window menu, go to Animation, Animator. Now, with the player selected, you'll see that the walk animation is currently set as the default animation state. Let's fix that. Before we start flipping the sprite to face left and right, we need to actually create a sidewalk animation for the player. First, select your player game object in the hierarchy. Then head over to the Animation tab, the same one we used for the idle and downwalk animations. In the animation window, click the drop-down next to the clip name and choose Create New Clip. Name this one Player Walk Side and save it in the Animations folder. Now head to your Sprites folder and select the frames for the sidewalking animation. These usually show the player facing sideways. Shift+click to select them all, then drag and drop the frames into the timeline in the animation window. As always, if it looks too fast, stretch the animation by dragging the timeline keyframes outward. And don't forget to copy the first frame and add it at the end. That creates a nice, smooth, looping animation. Now we've got a proper sidewalking animation, perfect for use with horizontal input and sprite flipping. Now that we've created separate animations for walking in different directions, it's time to clean up our animator and replace everything with a blend tree, a much better way to handle 2D directional movement. Open the Animator window and you'll see the entry and exit nodes, along with your old idle and walk states. Go ahead and delete all the animation states so we can start fresh. Don't worry about the entry and exit points. We won't be using them in this setup. Now right-click anywhere in the Animator workspace and choose Create State from New Blend Tree. Let's rename it to something clear like Player Tree, and then double-click on it to open the Blend Tree editor. By default, the blend tree uses a parameter called blend, but for our top-down player, we need to use two input parameters, one for X and one for Y movement. Click the Parameters tab in the Animator window. Rename the default parameter blend to Xinput. Click the plus icon and add a new float. Name it Yinput. These values will later come from our movement script. In the inspector, with the blend tree selected, change the blend type to 2D Simple Directional. Then make sure that the two parameters used are Xinput and Yinput. Now we'll add 4 motion fields, one for each movement direction, right, up, left, and down. Click plus, add motion field 4 times. Assign the appropriate animation clips for each direction. Our first motion will facing the right positive one for the X and 0 for the Y. Second one is 0, and 1/3 one is -1 and 0, and the last one is 0 and -1. For the walk left animation, we'll use the same walk side clip, but later we'll flip the sprite using sprite_renderer.flipX. Now we've got a proper 2D blend tree that will automatically transition between different walk animations based on input direction. Next, we'll go back to our movement script and hook up the values for Xinput and Yinput and add sprite flipping when going left. Now that we've built our blend tree with X input and Y input, let's update our movement script to actually send those values to the animator. Open the player movement script. At the top of the class, let's add a reference to our animator component. Now inside fixed update, right after we capture movement, let's pass the input values to the animator. These values will now drive our blend tree and control which animation gets played depending on the direction. Back in Unity, don't forget to drag the animator component into the animator field on your player movement script in the inspector. Hit play, and now you'll see that your player transitions smoothly between up, down, left, and right walk animations, all based on your keyboard input. One last touch. If you're using the same sprite for left and right movement, you can flip it horizontally when going left. Now, to make our player actually face the right direction, we need to flip the sprite when moving left. All we have to do is add a reference to the sprite renderer and flip it based on horizontal input. Now inside the fixed update method, right after setting velocity and animator parameters, add this logic. This will flip the player's sprite when moving left and return it to normal when moving right. Make sure your player game object has a sprite render rand. Drag it manually into the scripts field in the inspector. Hit play and try moving left and right. You'll see the sprite flip smoothly based on direction, just like you'd expect in a polished 2D RPG. And that's it. We now have movement, animation transitions, a 2D blend tree, and directional flipping all working together.